Hello, ladies and gentlemen, and welcome to Distance Learning. This is textbook chapter 7, and it's lesson 7.1. It is our class's unit 4. It's our fourth unit that we're looking at, but it is the textbook chapter 7, and that's what we're going to call it. We're going to be talking about multiplying two binomials today, and last week we talked about what a polynomial was. We had monomials, binomials, and trinomials. A monomial could look like this. This could be a monomial. This too is a monomial. And this is a monomial. So all of these are monomials. They're single term expressions. They're not equals. There's no equal sign. There's no equation. It's just a statement like saying tree or dog or cat. Okay, there's no equality here, where it's just a mathematical entity. These things have a numerical coefficient. They have a 3 is the numerical coefficient. This has an invisible 1 as a numerical coefficient. This is 3xy's, and this is 9x squared. They all mean, basically, now I'm making an equality statement. So this means 3 m's being added together. This is simply 1a. Now you get the idea of that invisible 1 being there, representing just 1. This will be 3xy's. So it's actually 3xy's. The xy is one term. They're being multiplied together. So it's an xy plus an xy plus an xy. And this would be 9x squared. So it would be 1x squared, 2x squared, 3x squared plus x squared, 1, 2, 3, 4, all the way, so that there were 9 of them. Okay? So that's what these all represent as a monomial. Now, how do we go from a monomial to a binomial? Well, let's start off with our monomials again. Whatever I had. There they are. There's my 4 monomials that I chose to deal with. And I can make them a binomial now. So now this expression is a binomial. This whole thing has 2 terms. That now has 2 terms. I'm putting brackets around it just so that you can see that I'm thinking about the whole thing as one entity, not 2 separate terms here. So maybe this one could be minus 9x, or maybe this one is plus, I did plus x cubed. And again, we've made binomials out of these by taking a monomial and a monomial and separating them with an addition or a subtraction. That gives us a binomial. So all of these are binomials. The most general case of a binomial, we just say it's a plus b. Okay, so that's a binomial being added together. And if I wanted another one, I would call it c plus d. Okay, so there's one binomial. There's another binomial, and they're being multiplied together. This is going to require something called the distributive property. We're going to want to take these two things and multiply them. Well, what you do is it's going to look like this. You take the first term of the first bracket and you multiply it by both terms in the second bracket. So this a gets multiplied by the c, and this a gets multiplied by the d. Now, don't want to confuse anyone, but what that would look like is a times c plus a times d. So a times c is a times c. A times d is a times d. Then what you do is you take the second term in the first binomial and you multiply it by each term in the second binomial. So b times c, notice I put a plus because it's positive b plus positive c. No, sorry, positive b times positive c. Now it's going to be positive b times positive d, which again is a positive, and we end up with that. So this binomial times binomial ends up giving us a polynomial of 1, 2, 3, 4 terms. Okay? So a binomial, so when you take 2 terms and you multiply them by 2 terms, you're going to end up with 4 terms. And that kind of makes sense. I took 2 terms, multiplied it by another 2 terms, and expanded it to get 4 terms. That's what we're going to be doing today. Now it's easier without the A, B's, and C's. This might have been a little confusing, and that's okay. You can stop this video and watch it again and go back over it. And then when we start doing it with numbers, it's going to get easier. Yes, this will be confusing at first, but it's something that will get easier with time. So what is an quadratic expression? We've talked about what two binomials multiplying together might look like. Now we need to talk about what is this idea of a quadratic expression. Well, in grade 9, you did a lot of work with linear expressions. And those were things that made lines. Okay, so when we graphed them, we got a line. Now, it might have been a line that looked like that. It might have been a line that looked like that. It might have been a line that looked like that. But all in all, those are all linear equations. Well, a quadratic looks different when you graph it. A quadratic's going to look like that, or like that, or like this. Those are all different quadratics. Okay, sorry you didn't see that one. There's another quadratic. Those are all different quadratics. And a quadratic equation, when it's graphed, gives us this U shape. We're going to call that a parabola. Now, I'm getting ahead of myself a little bit, but the equation that made lines, the equation that worked out for lines was mx plus b. You remember it as y equals mx plus b. In other words, things like y equals 3x plus 4. That made a line, okay? Notice that we had an x value here. We had a number, and sometimes we had other numbers being added on to it to make a polynomial, but it was this single x term here. Well, what we do to get quadratics is it's not an x term like that. It's now going to be something like that, perhaps. And the biggest difference is the inclusion of this x squared term. That's what gives us quadratics. Whenever we have an x squared term and it is the highest, in other words, the number up here, it's the highest degree variable. And again, I'm using language here that's a little bit confusing, but we're going to get it. So this would give me a quadratic because it has an x squared. This will give me a quadratic because it has an x squared. That will give me a quadratic because it has an x squared. When you have the x squared, you get this sort of shape happening. This will not give me a quadratic because it's not an x squared, it's an x. The highest degree, the highest number up here is a invisible 1, and that will give me a linear equation. So, when we come to our notes, we're going to talk about a quadratic expression. Now, an expression is no equality. There's no equal sign, which gives you a left-hand side equals a right-hand side. There is no equal sign. It's just an expression. It's a statement. There's no equality here. So ax squared plus bx plus c, this will give you a quadratic because there is the x squared term. Yes, there is an x term, but the x squared term trumps. And that's going to give us a quadratic, which means that we're going to have a shape when we graph it that looks kind of like that. Okay, the product of two binomials can be found by multiplying each term in one binomial by each term in the other. That's what I was talking about just a minute ago. The only new thing here is this word product. We need to know what that word means, and that means the answer to a multiplication question. So the product of two binomials really means the answer when we multiply two binomials together. Our first example is find the product of this binomial, 2x plus 3, times this binomial, x plus 1. We're going to stop the video here and then we'll start up again.